All right, everyone. Kind of on our theme of how we're moving through this, we're going to kind of did some of the planning stuff. Now we're going to talk about the displays. A lot of it's getting harvest command set up for the 250, 260 series combines and the 160 series combines are all running harvest command automation, where the machine can go ahead, self-adjust, help you be more productive, capture more grain as you're harvesting. So we kind of want to go through the basic setup of that getting started today. Kind of looking at your display, if you're running, I know we got a few customers that'll be in the 260 series combines this fall. The setup is the same. It'll be a little bit different on the display, but what you got to do to set the machine up, what you do to the screen to make adjustments to get it dialed in the way you want is going to be the same as with the Pro 700 combine or display. So looking at the display to start with, if you look at one way to tell if you're in automation on these combines can be turned on and off. If you look at your loss funnels on the display, if they got those black triangles at 3/4 full on the funnels, that tells you that you're in automation. Up in your headliner, bottom row, first switch is your mirrors, second switch, I can't remember what it is. Third one that shows a combine, it says auto. That's a rocker switch. If you hit the rocker switch once, right now what you'll see is these triangles go away, the A goes out of the cab. That means you're not running automation. It's like setting a prior combine, a 240 series. Anything, any adjustments that need to be made by the combine. It'll give you loss readings, but it's not going to try to react to it or make any changes based on that with the display. So typically on a combine, we'll set up run screen 1 down here. It'll look like this, where you got a cross section of the machine and your loss funnels below. This is where you'll do your adjustments to fine tune to get that combine dialed in. Kind of looking at what's on this display here, start off up here at your rotor RPM. Down at the bottom is going to be your fan RPM. Where it says 13 right there, that is your concave clearance. And then the 3 back here, pre-sieve, upper sieve, lower sieve. And then your vane position. It's got adjustable cage vanes. We can go ahead and move the crop through quicker by laying down flat or stand them up, and we can get more revolutions around the rotor. And that's in-cab adjustable. Looking at this display, when you look at the display, everything on this, if you're running automation, the machine has the ability to make changes for you, except for your concave clearance. So right here, number 13, that is always set by the operator. So typically corn, you're running somewhere 24 to 26, 28 concave clearance. You need to set that up yourself. And then for soybeans, somewhere in that 15 to 18, 19 is usually the range that people wind up in when they're threshing soybeans. So just keep that in mind. If you went ahead and switch from corn to soybeans, let's say he's running 28 concave clearance in corn, you want to do soybeans, you forgot to adjust it, what's it going to do to your threshing ability? Probably going to be kind of weak, right? And with automation, it may see that, hey, we got rotor loss. Well, the rotor loss is attributed, we're not threshing good enough. You would have to make that change to your concave to get that dialed in. But the rest of the stuff, the rotor speed, fan speed, your cleaning system adjustments, and the vane position in automation, the machine will go ahead and make adjustments for you. Your loss funnels, you kind of look at them across the bottom. They're split in half from what you may have seen on the previous combine. First one here is going to be rotor loss, the first half funnel. Grain damage, where that ear of corn is, that's looking for split soybeans, cracked kernels in corn. If it picks it up with the grain camera, the more it sees, the more it's going to fill the funnel. Tailings volume's in the center. This little pile of straw here, that's your MOG, material other than grain. How clean is the sample? Do I have just grain in my grain tank, or do I got a lot of trash in there with it? It picks it up with the grain camera. And then the last one over here is your sieve loss. When you're looking at setting an automated machine, the way that it's looking is as you're running, when we're below those triangles at 3/4 full or below, there's no need for the machine to make a change. You might see them dither up and down, but it hasn't hit the threshold where it says, oh, I'm doing a poor job, I need to make some adjustments. And that's one of the biggest changes from people coming from a 240 and prior. You guys typically set them so that if it's half full, I'm in trouble. You turn your sensitivities down, it doesn't feel that. If you want the machine to react and make changes for you, we've got to have it fill in that funnel, and at times when it's doing a bad job, when you got losses or you got a dirty sample, we want it to go in the red. When it gets up above the 3/4 full into the red, that's the trigger saying, hey, it's time to make adjustments. So that's one of the things that you got to do. It's a little bit different. A lot of people over the years, they get their machine dialed in and they want to see that down here at the bottom quarter of the funnel all the time. Here you need to, if you want it to make changes for you, to make adjustments and do a better job, it's got to be dithering around that 3/4 full. And you do that with your sensitivity settings. And I'm going to jump in real quick on the sensitivities here. So if you look right now, rotor loss sensitivity is at 62. If I went ahead and ran it down at 10 all day long, how much is my funnel going to fill? Very little. It's going to take a lot of grain hitting it to start bringing it up. What if I moved it up to 95? You might have one hit every 2 minutes and it's enough to put you in the red, and it's going to be trying to adjust. So your sensitivity is adjustment that you're going to use to dial the machine in. Whether it's rotor loss, sieve loss, or your grain damage or MOG. What you want to do, automation doesn't mean I can stay in the cab all day long and never look at what's on the ground or look what's in the cab. Early in the season, it'll take a few passes, a few times, but what you want to do is if you've got, if you're sitting here and it's staying down here in the green all day long, or as you're harvesting, you look behind the machine and you start doing your loss checks, and you see material on the ground, more grain than what is acceptable to you, and this is staying down here. What I'm going to have to do is take my sensitivity for rotor loss or sieve loss, start increasing it so that it fills that funnel. Once it gets to that threshold and it says, okay, this loss is unacceptable, I've got to make my changes. Are you guys good with that?
So one thing about setting your sensitivities, of course we're not harvesting right now. Whenever you do start, those 4 or 5 buttons there along the bottom, they'll actually light up. Whenever you touch them, you'll get 4 options, maybe a 5th depending on which one. But you'll get options that say, you know, more is acceptable, acceptable, too much, or way too much. Those I like to use those as a course setting. You know, brand new machine, first time out in the year. Use those to get in the right ballpark. If you're running along and somebody's following behind you, talking on the radio, give you a call, whatever, say, hey man, we're dumping a ton of corn out and this thing's not telling you anything, tell it way too much. That'll get us moved up real quick into a right range. From there, then whenever you touch those buttons on the bottom, you still get your bar graph, just like we're used to. We've had it forever. From there, you can move that bar graph, you know, 3, 4, 5 in one direction or the other, and really dial that in, make that machine run the way that you want. I've got a lot of guys that have run these machines for several years now that still just rely on those 4 buttons. And I'll show up because he says his automation's not running, he's frustrated, he's turned it off. I get there, we turn it back on, and you know, his sensitivity's at 3. But no wonder it's not running right. We're not even close. Or it's at 98 and it just stays in the red the whole time. You can't figure out why. So just keep that in mind. Use those 4 buttons as a course setting whenever you change crops. You know, if you go from 27% corn to 12% corn, 15% corn, use those settings again there to make that big jump and then dial it back in.
Sometimes I'm running and my funnel filled red for like a half mile through and make absolutely no changes in the machine. What should I be doing?
Do you get any icons up here in the top telling you like what the limiting factor is? It's speed.
Are you running feed rate?
Yeah.
Okay.
Yeah, because usually and what the machine will do is, let's say that rotor loss is high for an extended period of time, and it's making its adjustments. It's changing the vanes, it's changing the rotor speed. And after several minutes where it's making changes that can't get there, usually it'll come up and put an icon on here that'll tell you what the limiting factor is. It may say, you know, it's basically made the changes that it's capable of making. We still haven't got there, you're still in the red. That's when you want to look, see if for some reason where your sensitivity's at, if you've been, you know, running a 62 sensitivity for some reason, you may have changed it, or look to see if we're set up good for on your concave clearance. See if the rotor speed seems to be a logical rotor speed for the crop you're harvesting. Then the other thing to check is what would happen if, and we'll talk about it later, if your concaves got shagged up, they got plugged. Is it going to get all the grain out? It might be a physical limitation on the machine. When you start looking at how this, in some of the, I think the best thing for me to get my hands around it, of how this works, is you got to think like a computer. Guys programmed in what to do. So when it starts seeing if rotor loss is high, it's got two corrective actions that it can do. It can change your rotor speed, and it can change your vane position. That's what it's got to correct a rotor loss. Same for grain damage. It's two corrective actions. Number one corrective action for grain damage is slowing down the rotor. If it starts seeing that we're splitting a lot of soybeans or busting corn, it wants to go ahead and slow the rotor down to be less aggressive, less impact on your grain. And then when you get over here to your cleaning system, it's actions that it can do to reduce sieve loss would be to open up the sieves more or slow down the fan more. If it can't correct it and it goes through its gamut, it's got my sieves open, I've slowed down the fan, it's still seeing losses, it's still that funnel's in the red, then it'll give you an icon saying unable to achieve acceptable performance. And on that, what could be a cause of you can't get sieve loss under control in corn? Usually for sieve loss, concave clearance doesn't affect us. Corn's a unique one. Sometimes we can, this is something to remember, we can pick up rotor loss on our sieve loss sensor at time in corn. And what happens is if you got a lot of rotor loss with your knives out, you got some grain that comes through those slots where your knives come in, and it actually hits your sieve loss sensor. I've chased that a few times before. It's saying that everything, my losses are from the sieves, but it's the rotor loss because in soybeans when you get your knives in, those are blocked. You don't pick up rotor loss in soybeans with your sieve loss indicator. But the other thing that it could be, if you can't get sieve loss under control in corn, it could be the distribution coming off your rotor. One side of the sieve is loaded up heavy. It's got a lot of grain on it. The other side is lower. But at the end of the day, it's picking up that we're walking it out, and it can't correct it by opening sieves or opening closing sieves or adjusting fan speed. On that, you may have to look at shifting rotor modules or putting a little bit of offset into your cleaning system.
So on your question, I guess the first thing that I would ask is, like, if you called me with that scenario, is are you actually losing grain? Is it a sensitivity issue where things have changed? It's a different variety. I was talking to Alex wherever he is. I got a customer that last year year before, he had one variety of corn that in a single down he would plug every module in a combine. Did it 3 times. He made 3 passes. Every pass did it. We were losing it. We knew what the issue was. He pulled out, went to a different variety. Everything ran fine. Came back a week later, and it ran through the combine just fine. If we are losing it, like Tony said, there's a lot of different things that we can address to figure that out. If we are losing it and the automation is not changing it, and it's something we'll show you in a little bit, I'd reset the automation. It's always learning. It's always trying to figure out what it needs to do, to what changes it needs to make for whatever circumstances it comes across. So by resetting automation, we just wipe its memory, tell it, okay, we're going to start back from the day you were new and go at it again. I don't know what would cause that exactly, but that's something that I've had to do several times. It's in the display right with the automation settings, so it's something that you can do, something that Case kind of encourages as, you know, this is the first line of defense. If automation is acting funny, reset it, try it again. Does that make sense? Answer your question?
Yeah, I've reset automation many a time.
Okay.
All right, then one more question.
Yeah.
The rotor loss, the only way, you have to do a kill stop to diagnose that, or is there any way to really
Separate rotor from sieve loss?
Yeah.
say, well, I'm losing grade, is it the rotor or the sieve?
Kill stall is probably the best way of doing it.
Yeah. The other thing, depending on which spreader you have, if you would have a vertical spreader, you can, and with a windrow chute, you could open that up so that all that's coming out of the rotor is going into a windrow, and then anything coming off the sieve is going to go through your spreaders yet. That way, if it's spread out wide, it's sieve loss. If it's coming through the chute, then you know it's rotor loss. Is a way to check. But kill stall is a good diagnostic tool. When I'm having trouble setting a machine, I'll do a kill stall. And a couple things I look for is kind of talking about how many of you guys have done kill stalls in the past? I think we'll just go talk about that right now. But
yeah, we
essentially,
can go through calibration procedures now.
Yep. On the 250 series, we put it in where there's an automated kill stall in the procedures.
Has anybody done it on 250? They put foot
So
pegs in there for a reason. It's
There's a
going
kill
to throw you
stall.
up in the steering wheel when you do it.
So a kill stall is basically, we want to, it's kind of like going through an MRI for your body. We want to see what's going on inside this machine when it's under load, to diagnose what's going on. So in the 250 series and 260 series, we've got this kill stall procedure. If I go ahead and hit this, it'll tell you what to do. You hit OK when you're ready, you're armed, then you'll want to go ahead and get your machine loaded up, whatever you've been harvesting at. If you've been harvesting at 5 miles an hour, wait, you start seeing that funnel go in the red. Okay, this is what I want to see what's going on. When that happens, hit it. It goes ahead and shuts down the machine, tries to do a quick stall or a quick kill on it to go ahead so we can diagnose to see where our grain's coming from. Is it coming off our sieves? Is it coming out of our rotor? Shut the machine, or shut your separator off, come back to neutral, restart your engine, let it cool down a little bit, get it cooled down. Then you can shut her down and take your panels off and start looking. After you're doing a kill stall, usually a couple things I look at is opening up the back of the machine, take a look at what my cleaning system's doing. A good running cleaning system, typically you'll have material about the first half of the cleaning system that'll still be sitting on it. The back half should be blown pretty clean. And then look at your grain pan. It's not too much of an issue in soybeans, but in corn, the rotors can discharge more on the right-hand side. So if you got a pile this high on the right-hand side, this much on the left-hand side, what can happen is the air is going to take the path of least resistance. So when this comes onto the cleaning system, the air hits it, this blows out really easy, the air starts going that way, we don't get enough air on the heavy side. So that's what I look for too. First thing, and you can tell if you got material all the way back to the rear of it after a kill stall, chances are you don't have enough air, and that material that you see on the back half of the sieve has probably got some grain with it, and it's going to physically get walked out of the back of the machine through this shaking action. After I do that, then open up my side panels, and then I start looking, make sure my concaves, nothing's plugged here, and then I start getting in there. Usually look at the back 2 rows for grain at the back 2 rows of the grate section. Typically, you're going to find a little bit of grain here. When you get into that 4th row, if you're finding more than a kernel or 2, that's probably telling you that you got some rotor loss. Another look at the back of the machine is look at your grain pan, or the chopper pan underneath your rotor. If there's a bunch of grain there, you know that's passed through the rotor. The only way it can get there is from that. That's another area to look to see. Then once you got it determined, hey, my sieve's doing good, my loss has got to be coming from the rotor. Then you can start looking at what adjustments to make on the rotor, or vice versa. Rotor looks clean at the back, the chopper pan looks good, but I've got a lot of material towards the back of my sieves. I got to do something on my cleaning system. That's how you'd use a kill stall to help diagnose which direction you need to go on. Because, like I say, if you just walk behind the machine and say, whoa, I got a lot of loss here, and you don't figure out which system's giving you the loss, you're going to kind of be chasing your tail for a while.
When you reset automation, does it just reset the automation for the work condition you're in, or does it reset all of them?
I think it's for your work condition. Should be tied to the work condition. And kind of, once again, you got to figure out how they put this system together. For your work condition, when you reset automation, let's say we stay with our standard default automation or work condition. We start harvesting. We've harvested 800 acres. It's remembered all the data points from those 800 acres. And you may have started off in a wetter, tougher condition. Now the crop is dried out over time. It's still got some of that data from the first ones. When you reset automation, it takes that buffer that all that data stored in, wipes her clean, and it starts off taking data from the crop that you are in right now. That's what you're doing when you reset automation. You're taking some of that old data, which was valid 2 weeks ago. It may not be helping you with today's harvest. Reset it, start off with the fresh data in that buffer that it's going to go ahead and make its decisions off of, is what you're doing.
When we're running auto on beans, during the day, it seems to be fine, but when you first start in the morning, the beans are real tough or whatnot, it seems like it wants to keep the rotor running real slow. So I got to go in manual for, an hour or something, I got to beans dry out. Is it typical, or?
Yeah, that's what I've seen. First thing in the morning, probably my biggest complaint, first thing in the morning or push it late in the evening, it seems like it doesn't want. Typically, if you were manually running it, you might be at 620, 650 in the day. You get towards evening, you might be pushing 700 on rotor speed. It doesn't seem to want to bring it up. There's a couple things you could do to, if you wanted to stay in automation to make it work in those conditions, that we can set that machine up for. And we'll talk about a few of those changes we could make.
Is there like a minimum rotor speed or something?
What we can do is play with the ranges and maybe have a different work condition. Do a heavy dew beans and dry beans or something like that, and we can adjust the ranges for those harvest conditions.
How many people are running 2 combines in the same field? Several? How many of you guys have heard of Accusync? So there's a few less hands there. So Accusync, something that's been out for 4 or 5 years now. Had some issues up front. If you guys had been around it, the first year it was rough. Last year, I didn't have any problems at all with it. It's something that will share guidance lines and coverage between the 2 combines. Shares it live. It only shares coverage, so you can't see his yield maps or the other combine's yield maps, the other combine's moisture maps, so you just get their coverage. But with that, your auto cut width will work correctly. That first guy that breaks through cutting beans, the second guy has already got his guidance line, so everything matches up. Just something I wanted to make sure you guys were aware of. It's something that I feel like we probably haven't pushed a whole lot because we had a lot of problems with it, but now that it's working, it's definitely something that's worth looking into if you're running more than one machine at a time.
So when we were over there chatting earlier, we were talking about variety tracking, exporting out of the display or out of field ops to go to the display. We talked about doing it over the air or doing it via USB. So when we get to that machine, we're going to pull out that old USB before we even turn it on. So what I just did, don't do that. Anyway, so you're going to pull it out, then you're going to key on the machine, delete the old data out. Once you do that, we're going to turn it off, have the screen black, and plug the new USB in. When you do the new USB and you key it on, all that data should come in. So really hoping that data comes through right now. And the way to check that is we'll go to data management. We're going to go to map. We're going to go to our growers, and we're going to select our growers. So my grower for my new USB is Whitney-Welker, and that would be popping up through here. So if we did a key cycle, it would pull through. But to be able to see that variety tracking, we would go to our layer, and right underneath obstacles would show variety tracking, and you would turn that on to color. And then when you select your grower farm field, it will show you the 2 different varieties, map and color, like we did on the field ops display, along with, you could go right beside layer, and it would show you the legend for where it's at in the field. So you can look at that and check it out here on this display. And then we'd go to our run screens. And in our run screens, let's check this out real quick. Okay, so no run 2 has a blank. So we would go to toolbox, layout, and then this is how you guys can edit your run screen, so what fits you and your needs. At Bane-Welker, I know some of my guys are the technicians. They will create a run screen for you guys, what they think you need, but you can also add things that you want. So we'll go to like run 2. We see we have a blank here. We go to that blank, oops. And in alphabetical order, there is a bunch of things you can choose from. And of course, mine's at the very bottom. Okay, well, what's up one? So then this is where we can do variety tracking. If you want the legend variety, so the 2 I typically do is just variety tracking and variety. So while you're running through that field, you can see the variety being harvested. And then when you click variety tracking, and we go back to your run screen, you turn that on. So I always have variety tracking right here and then variety right beside it, so you can see it. So if we were going through that field and we had variety tracking in here, you'd be able to see like Pioneer whatever. So yeah. Anything else you're thinking of? Cool.
Does anybody got any questions about variety tracking? You guys using it now? I run a mixed fleet, mixed mocks to everybody. Some guys really get into their data, some guys really don't care. So.
Yep, in field ops, I have a guy that has a red combine and a green combine, and when he exports out variety tracking, he'll do it for both the red and green, because field ops has that capability for that green display to move data to it. So if you guys want to work on that too, if you're a mixed fleet, we are kind of colorblind sometimes, so on some instances. So yeah.
All right, before we jump into automation and kind of going through the screens, Caleb Winger, we want to talk just a minute about our Raven card automation, something pretty new with us. I've had it on since we've been running it, what, 3 years now? So something we've been beta testing. We've got a rebate out for it. Caleb's going to talk a little more about that.
Okay, so yeah, while we're here talking about, it's called RC Raven Cart Automation, and what that is right now in this stage is basically it's the autonomy for the combine and the tractor. So if we're in the field and we've got some cart operators that need a little more practice, what this does is allows for the tractor to be set up to where the combine controls the tractor. You basically got the guy in there sitting on a seat switch to make sure that it doesn't run into the woods or anything like that. But it'll be to where all we've got to do is we go dump on the semi there, and then the operator just hits the auto guidance button just like normal. Nothing changes. It's not any crazy different run screen or anything like that. He just hits his auto guidance button and then the shift button on the back, and what the tractor will actually do is gear up, speed up, drive to the combine right underneath. It is set to the middle of the auto cart on the spout from the combine. It's called a set point. We set that and it'll drive to. Once it gets to the tractor, it'll slow itself down and then match the speed of the combine. So once that gets done in the combine, you've got a little knob right there next to you. You can feel the front of the cart, back of the cart, and it's a roll dial. So it's not like you just push front of the cart jumps forward. And then if you grab that handle in the combine, it knows to get the tractor out of the way because you're going through a dip and you don't want to wreck your auger on. It's some of the kind of newer technology that, once again, in Matt and I's area, we beta test a lot of stuff it takes. We get to see a lot of the new stuff first. That means we get a lot of the headaches first. We got to fix it. But this is, like you said, I've been going on 4 years now.
3 or 4.
It's working this year absolutely amazing. And then, like I said, if you want to try it, if you want to look at it, I do got a kit, and then also there is some rebates and stuff like that. There is some unlocks that has to go on the machines that they're giving you for free. So we're getting the tractors unlocked for free and stuff like that. I got to be on RTK, so that's my spiel on that. The only other thing, I was back there talking while they were talking about some of the automation that come on. When we're setting up those jobs, one of the biggest things to remember is when we set up that job to send to the other combine, the guidance lines don't automatically go. Okay, once we get in there, that's got to be selected to send as well. So just something when you're thinking about when you're running both machines in the same field, that guidance line isn't automatically set to the job. So once again, get a hold of your PF individual or some technicians if we're getting that set up for the first time, kind of. Because we want it to be a good experience. And when it first came out, I've been with Banes for 12 years. It was not a good experience at all. A lot of headaches. But now we got our dialed in, and I'm pretty confident in this.
Yeah.
You pretty confident in it,
Yep.
Tony? Good, because I'm gonna call you.
So we're going to run through some of the automation pages. How many people are going into an automated machine for the first time this year? That helps. So to get there, there's 2 different ways. Whenever I set up a run page, I always put a shortcut button up here at the top. It's one button push to get into automation at that point. The other way that seems like is hardwired into my brain is hit back and automation. We've got a whole slew of different pages here that all have different information on them. So that looks different than Tuesdays. So the first page that's going to come up is basic. It's pretty basic. You set your crop type, your work condition. Your strategy is our first setting that pertains to automation. On performance, we've actually got 4 different strategies to pick from. We got any food grade corn, white corn guys up here? Seed corn, seed beans, a little bit. For those crops, best grain quality is going to be what you're wanting to get that incentive to raise those crops. It's going to slow down our rotor, it's going to open the veins up, it's going to be as gentle as we can on the crop. We're going to sacrifice maybe a little bit of trash, maybe a little bit of ground speed. We're going to put the best quality crop that we can in the tank. Performance is the one that I run on all of my guys except for 2 that both raise white food grade corn. Every other time I run performance, and it is kind of a happy medium between getting good grain quality and getting acres covered also. Maximum throughput is exactly that. We're going to run the machine a lot harder. We're not as worried about, if we lose another bushel or 2 on the ground. We're not as worried about getting a little dirtier sample. We're covering acres. And then fixed throughput is something that I've got several guys that have started to use. I'm guessing the labor problem isn't any different up here where nobody can find cart drivers, nobody can find truck drivers. Fixed throughput's kind of nice if you're short on truck drivers. You can set it up so you've got 4 trucks. Takes them an hour each to circle around. We can set our throughput on the combine so everything stays rolling. You're never sitting in the edge of the field with combine full and grain carts full and waiting on a semi. So we can slow everything down and match what production can handle.
I want to say, just to add a little bit, for best grain quality, what it winds up doing is it looks at your sample and damage first, and it adjusts for that, and then it adjusts for losses second. When you go performance, it adjusts for losses, rotor loss, sieve loss first, and then secondary, it tries to reduce grain damage and clean up the sample. Is the difference between the two. Your max throughput and fixed throughput only come into play when you are running feed rate control. If you're using the feed rate control, that'll automatically speed up and slow down the combine to keep it loaded. What it winds up doing is in max throughput is it's going to try to run at your max ground speed, which we'll talk about here in a little bit, or max engine load. It's going to try to hit one of those two. And if while doing that, when it speeds up and gets up to 5 miles an hour, some losses start going higher, automation will try to adjust for the losses, but it will not limit ground speed because of the losses. And same on fixed throughput. If you're running at 2,500 bushel an hour, it's going to try to get up to that 2,500 bushel an hour, stay there, make adjustments to do the best job it can, but it's not going to say, oh, I'm going to drop back to 2,000 bushel an hour because I've got losses. That's the difference between those four strategies.
So the next two, target max ground speed, target max engine load, they're both feed rate settings. How many, I know you said you were running feed rate. We got a lot of guys running feed rate, hate feed rate, even know what feed rate is. Guess we don't know what feed rate is.
Feed rate, it's a button on your propulsion handle, and it looks just like this icon right here. It's got a little speedometer. And when you go ahead and you engage feed rate, what you'll see is that'll go from grayed out to colored. When that's colored, what the combine's going to do is try to speed up to that max ground speed or max engine load to get the capacity out of the machine. And once it gets there to say 100% engine load, it's going to vary the speed up and down to keep it at 100% engine load. If it gets up to 5 miles an hour and you're still at it, say 90% engine load, he said I can't go, you're not allowed to go any faster than 5. It's going to sit there at 5 miles an hour. Is what feed rate does for you. A couple things, if you haven't used it and you'd like to try it, when you first start it, the first time you engage it, you got to press and hold the button for 2 seconds on your propulsion handle. And you'll see this here, it'll come colored and it'll put an hourglass or pause symbol over that feed rate speed. What it's doing is it's looking at your engine load, your ground speed, and what's going up your elevator. It's taking a snapshot of that, saying this is kind of where the guy wants to run it. So the key point when you press and hold that for 2 seconds, what you want to do is be in crop and be loaded up close to where you want to be running. So I've got it set for 5 miles an hour, 100% engine load. Get the machine up to 96, 98, 103% engine load, someplace close to your max engine load, and do that calibration. Press and hold it for 2 seconds. It'll go put the pause symbol up. Once the pause symbol goes away, what you'll see here is your ground speed, and then this one here will show you what your target max ground speed is. So on this case, if I engage it, it'd say 5 miles an hour here, and I'm running 4.6 or whatever it winds up being. And you'll see it speed up and slow down as crop conditions change to go ahead and keep that machine at peak productivity. You're not going across the field and you take a phone call and the crop got lighter and you look over, I'm still running the same speed, but I'm at 89% engine load. The machine can handle more. So with feed rate, it'll speed up and slow down for you. Second time you engage it, you turn around on the headland, you get in the crop, you engage it again, it's going to go ahead and just pick up. You don't have to do that recalibration. Where I do that push and hold for 2 seconds, going back to your scenario, you start cutting beans first thing in the morning, and they're going through tough. 3.2 is all I can get out of this combine because these beans are going through like bowling balls. You get in the middle of the day, they're nice and dry, it's flowing, now you're running 4.5, 5 miles an hour. As the load changes on the crop conditions change, just press and hold that button for 2 seconds. It's going to take another snapshot, pull your engine load, your ground speed again later in the day, and then you can run for that, and then you get into 8 o'clock at night, she's getting tough again. there's no way I can get up to that 4.5 miles an hour again. I can only run 3.5. Do another, you can do that, press and hold for 2 seconds. You can do that as many times a day as you want. But that gives it a starting point of what it's trying to achieve right away, and it'll try to get there quicker for you.
Go ahead.
Anytime you move your propulsion handle, it automatically kicks it out of feed rate. You'll see it go gray again, grayed out. You get manual control over it. So it's not something where you're coming up on a waterway and it's like, oh my God, I wish it'd slow down. Pull back on it, you can slow her down anytime. And a lot of people will kick it out while they're trying to top off a grain cart, depending on how skilled the grain cart operator is.
So that was the 2 caveats I was going to put out there.
Okay.
Be close to the, like Tony said, be close every time you engage feed rate to what speed you're wanting. I've had guys, you know, have it set for 5 mile an hour. They'll just barely get turned in, be running 2 mile an hour, hit the button, it'll speed up to 5 mile an hour, life's good. They get to the other end and they touch it and it goes back to 1.5 miles an hour because they pulled it back. It goes back to whatever position your hydro's in. So, and it does it right now. So either get real used to using your foot pegs or just try to speed up to whatever speed you're wanting to be at. The other thing is when you do hit your unload button, it locks your ground speed. So if you're trucking along, you know, 5.5, 6 mile an hour cutting beans, it's a good day, there's a big green spot coming, it doesn't care. It'll slug that combine full and it won't be apologetic about it. So I tell my guys, you know, when you're going to unload, go ahead and just tap your hydro handle. You're going to fill the cart anyways and speed up and slow down. Most of my guys tell the grain cart driver, hey, I'm cutting at 5 mile an hour. You come up next to me, lock in at 5 mile an hour, I'll do the rest. So you're going to want to be in control of the combine anyways. Before you hit your button, your unload button, just grab your hydro handle and take control of it. I've seen guys just plug away right into that green spot and 6 miles an hour and it's not pretty. So just wanted to put that out there, make sure you guys are aware of it. I've got some guys that really love feed rate. They use it every time. You know, newer operators that don't know what to listen to, don't know what to feel for. It's a great thing. You know, not picking on a couple of guys, but there's some more gray hair than I've got, so I'm guessing you've probably been running a combine for a minute. You may not like feed rate because you're able to look out and see what the crop's going to be doing before you get there. This is 100% a reactive system. It doesn't know that the crop's getting ready to go from 50 bushel beans to 95 bushel beans. So it's just going to go charging in there and hope for the best. So just be aware of that. Like I said, it's not for everybody. Some people really like it, some people hate it.
I got a question on that.
Yeah.
On my feed rate, there's a lot of times I'll be going along, and you know, all of a sudden I come to almost a stop. And in it, I always think, okay, it's going to pick itself back up.
And it doesn't. I had that problem 2 years, last year, year before, I can't remember now. I think some of that is software related because it was real sporadic. One machine would do it and the next 3 wouldn't ever. I mean, I never got that phone call, and this machine would do it, you know, a dozen times a day. Making sure that this is right, recalibrate your feed rate seems to help out a lot, like what Tony said, where you press and hold it. Yep. Calibrating or resetting your automation will help, because if your funnels are high, it's going to seem like speeds.
Funnels aren't high.
Okay. I would start with software then.
There's 2 other things. One is going on, as I said, on performance up here. If you say your funnels are staying low, so that shouldn't be an issue. But if it gets to the point where the funnels are staying high and it's making changes, its next thing in performance is start slowing down ground speed to keep the material in the.
My other thing is every time my combine powers down, it goes to desperate grain quality every time.
I know that's a software thing. I had them doing that last year and updated software, and it would stay where it was supposed to.
The other thing that you can do is, you know how we like using that shift button on the front of the propulsion handle? There is a function for that in Feedrate Control too. If you hit shift, header up, it changes the sensitivity level. If you're, so if it's slow to pick back up speed, try shift, header up together. You gotta be holding shift, otherwise you raise your header. But, and then for the same scenario, if you're coming into, you're going from 55 bushel beans to 70 bushel beans and they're getting tougher and you know it's gonna hit hard, the other thing you can do is shift, header down. It'll start slowing you down before you get into it. So that shift, header up and down, might help you fine tune that and make it more drivable in Feedrate Control.
Does Feedrate change the feeder chain speed?
Only if you were set up in auto feeder speed, and as your ground speed changes, it's going to go ahead and do it just like if you was manually driving it. If you're running a manual feeder speed or header speed, it's not going to do that. Same for reel if you're running
the auto reel.
Yep, if you're running auto reel, it'll work with Feedrate working too, because it's just looking at miles per hour and adjusting the reel to the feeder accordingly if you're in auto.
Okay. Our next tab's advanced here. Get into a little bit more of the automation settings. Initial settings, there's two ways that you can run automation. Under automatic, it starts from, I'm going to say, book settings. There's default settings that CNH said, you know, this is where we want you to start it for corn, this is where we want you to start it for beans, for wheat, whatever. It doesn't care what settings are in there. As soon as you kick on a machine, it jumps to the book settings. If you're the guy that wants to go out and set your own machine, you want to get it started, you like being in control of it before you want to let automation take over. If you change that to current setup will take that machine, you know, you go out, you make 5 or 6 rounds, everything's running good, you like the way that it's running, change it to current setup, turn your automation on. It'll take your settings that you had in the machine and then go from there making changes. I will say that one thing that every one of my customers, every one of my technicians has said is this thing sets sieves backwards. You know, on that machine, we open the bottom sieve, we close the top sieve, you just use your top sieve really. You run your bottom sieve wide open. On this machine, we'll start closing down our top sieve and leave our bottom sieve, or start closing them down separate of each other depending on what the situation needs. I will say automation from the very start has been pretty solid. As far as what settings it wants to do, there have been glitches here and there, but as a whole, trust it. If you've got good settings in there for your sensitivities, you like what you see on the ground, let it do what it wants with the sieves. Next one down here is your adjust frequency. I normally run mine on high. My guys like to see that blue icon come up and like to see those numbers change. It may change, you know, top sieve 1, but they like seeing it's blue. It's just a mental thing. Hey, I got this fancy new combine. It's going to set itself. They like seeing it set itself. I do think that the adjust frequency on high does make up for some of the inconsistencies we see in the crop. Not every one of these crops and every one of these fields is going to be perfect 200 bushel corn all the way across. Setting that on high does make up for some of that. I'm sure the guys out in Iowa and Illinois where it's good black dirt and you can see for a mile standing on top of a Copenhagen can, they can probably get by on medium. Around here it seems like I've got a lot more variability to contend with. Threshing condition is one that I don't think gets changed enough. I think this would be one for you. Threshing condition, we've got easy, medium, and hard. And it's exactly that. It's how easy are we threshing. You know, you were talking about your damp beans in the morning and then in the evening. If we go from easy to medium, it's going to hold your rotor speed high. It takes the bottom portion off of your rotor speed and says, no, we're going to hold you higher. So instead of, I know you were asking about a minimum rotor speed. This pretty well changes your minimum rotor speed. Also changes your vanes so that they're running a little slower. So we're holding that crop in our rotor a little longer making more revolutions, giving it more chance to thresh and separate. So if things are getting tough, you know, beans are a little green, not like, I'm sure nobody up here is running fungicide and got them green stem beans and they're the size of my pinky and
Thumb.
yeah, thumb. You know, as those conditions change, come in here and tell it that it's hard threshing. You know, we've got some spongy cob that's just really sucks getting the kernels off. Tell it that, you know, go from easy to medium or medium to hard. Now, there's a couple of times last year I ran in hard and it gets the rotor singing, but that's what it took to get it off the cob. So
Kind of.
It seems like sometimes the vanes will stick in one position or something. It gives you a message.
yep, so
Manually, and then they're okay.
yep, so that could be a couple of things. Whenever you cycle turn the separator off, it's supposed to run full swing. My guess though is it's software. I know I've said that a few different times and I hate being that guy. It's like, oh well, you know, it's software. But I had a guy, one of my customers at our clinic Tuesday, I got a phone call every day, all harvest long, 2 years ago, because he was mad that it kept coming up and saying, my vanes are plugged. Get out and clear the plug. And he'd just rock it and it would go away. Software, they've changed the amp load on what that little actuator's pulling. So if there is, you know, a little bit of bean dust or it is kind of plugged, there's a stem in the way, it'll push through that so that we're not getting that warning all the time.
Yeah. Kind
So I need to have a tech come out and
Yeah.
get the software up.
Yeah.
And kind of the background behind it is when automation, the machine's controlling it, it's looking at the amperage on that actuator. If it's trying to go to the end of the stroke and it sees an amperage gets so high, it shuts itself down. When you manually hit it, we put full amperage to it because we're not going to hold it. Because if it's trying to go to 100%, it gets to 98%. It's going to keep trying to push it till it either gets to the 100% or we see that amperage load. If we gave it full amperage, it'd stall out, start burning up the motor. So there's protection built in there. Reason why you're always able to manually do it is because when you use your switches, we allow it to go the full amperage. Is the difference behind that. But we've played with the limits on the amperage on that actuator, and I'm not going to say it's totally went away. It's a lot better than it used to be.
Yeah, a lot better.
While we're talking threshing conditions, I know we're going to jump out of order here, but to show you what happens on your threshing condition, if I go to ranges, turn them on. So right now we're in soybeans and we're easy threshing condition. And if I look at my rotor speed, our rotor speed for soybeans, easy threshing condition, that doesn't look right. 550 to 850 is what they're wanting to run. If I change, just hit OK, and go to hard threshing. Oh, you could do it on that screen too.
No, you were in ranges.
So we went to hard up here on threshing condition. Now if we look at our rotor speed, why is it showing the same?
Now you're 750 to 1,000.
Now 750 to 1,000. So it took, because if you think about it, if someone is running a combine and says, this is really hard threshing, what should I do? What would you tell them? Speed up the rotor and possibly close down the concaves. But we're not going to close down the concaves with automation. So when you change from easy to medium to hard threshing conditions, what we're changing there is we take the bottom end of the rotor speed out and we tend to pull the vanes back. So if you probably look at vane position here, down. So we're in hard. It's going to keep them from 0 to 0. If he's going to do this for yours, you'd probably want to go ahead and give it 0 to like 75, because you don't want to. The one thing you get by more rotor speed, you don't want to counteract by putting the vanes to 0. So that's what you could do to fine tune. And if you look at, go back to, we've kind of jumped ahead on the screen, but go back to ranges and go back to the top, threshing condition back to easy. So we typically like to start off in easy because it's going to give you the most rotor speed change, it's going to give you the most vane position range that it can work in to try to dial this machine in. When you start saying hard, medium or hard threshing condition, it's closing down the window. Now even on easy, if I wanted to go ahead and for soybeans, let's say look at the fan range that it typically runs. It runs from 800 to 1100, and from your history, anytime I get down to 800, if I've seen it go down to 800, my sample gets dirty. I don't want it to go to 800. You can go in here and change it to the minimum fan speed would be, the range would be 850 to 1000. So you can go ahead and for your setup, you can go ahead and make some changes to that. If there's some setting that you see that when my sieves get down to 15, I got a problem or something like that, and the range is 12 to 20, you could take some of that range out. But the more you go ahead and dial in your ranges, you're going to get to where if you make them small enough, it's got no ability to change because you've range locked it. You've bound it where it can't make adjustments for you. So that's what you can do on that ranges tab to help set up your machine. You can, like I say, if there's certain conditions that I don't want the machine going there, you can tell it not to go there or make it so it doesn't go there. But at the same point, if it needs to go there to reduce rotor sieve loss or get a better damage, it can't go there because you told it don't go there. So that's what you can do on that ranges tab.
Will you get a warning icon if you set the ranges and it wants to go?
Eventually you'll get the same icon you get. It'll say, you know,
not able to achieve satisfactory performance because of. And a lot of times, either you got, if you tighten down the ranges, you might need to open them back up. Or the other thing to do is look to see if there's something physically limiting you on the combine, plug concaves, or you don't have the right
openings wrong, or
concave opening is way off.
So we've got talk about threshing condition, our max rotor speed, kind of the opposite of what you were looking for. But if there's some reason, you know, our seed corn, we want to make sure that we don't ever achieve, you know, 400. We can actually put that in there and make sure that rotor stays slow. Our sieve load configuration is one that I like to turn on. When you turn that on, you get this bar over here on the side. That's actually telling you how much crop's sitting on your sieve. So we've got pressure sensors on both sides of the sieves reading air pressure. So with this graph, the way it sets right now is no pressure. So we've got nothing pushing down, nothing pushing up. As that bar graph comes up, it means we've got more crop sitting on the sieves. We're either making a lot of residue with our rotor concaves, or we've just got a lot of crop sitting on it and we need to open our sieves. If that bar graph comes down, it means that we're running a lot lighter. We're pushing up on the bottom of the sieves with our fan. So again, we either need to speed up and put more crop on top of it, or because we're running light, or we've got our sieves shut down and we're running light crop and we're holding the sieves up with our fan. I like running it. It's just another diagnostic tool, more information I can use to set the machine and have an idea of what's going on with it.
Typically what you're looking for on that sieve load is off to the side, you got line with an arrow up, a line with an arrow down. If you can stay between those two, you're using the capacity of your machine. Doing a good job.
Okay, if you run that, like in corn, we usually tilt our sieves. Mm-hmm. You still should have to tilt the sieve, that won't.
No.
No, that's not something automation's really looking at. It's something that I like to use to know if I've got, if I've got the sieve angle set right, if I need to put more angle in it, if I've got too much angle in it. Like I said, if we're creating a lot of trash off the rotor, or if we're running light and we can actually speed up.
Then reset.
Yeah, our reset automation, it's come up a couple times now. You guys saw me reset the ranges earlier. If for whatever reason, anytime, no matter what, he knows, automation starts acting funny, just reset it. Like Tony said, this thing's looking at our data from the day we start to whatever day we're on. If we get 30 days into harvest and we started with 30% corn and we're down to 18% corn, probably need to reset our automation and let it that 30% corn fall off what it's looking at, start looking at what's more current, so that it can kind of figure out what it needs to do from there, instead of lumping that 30% corn, that high moisture corn in with it and trying to build that into its strategy. Our sensitivities, we kind of talked about it. This is the exact same as what is on the run pages. Like I said, at the bottom, you've got, whenever you press your little box on the run screen after it's lit up, you get those 4 icons. Your rotor, you actually get a 5th. You can tell it that there's unthreshed grain. Whenever we go to fine tune it, there's a bar graph at the bottom of that box, or you can come in here and make your changes. So 2 ways of getting to the exact same data.
Then for your feed rate sensitivity, for guys that are using feed rate, usually we run that in high. There's 5 selections. High is the second from the highest. That's usually where we want it. Does a good job of getting you slowed down if you take in a big gulp and bringing you back up to speed after heavy load on the engine.
I scrolled down there, you guys saw the reset sensitivities. Same thing. If it's running in the red and you're trying to make adjustments and you've forgotten about the little bar graph at the bottom, just come in here and reset sensitivity, start over again. You got most of the time you got kind of an idea of where it needs to be. These numbers are usually fairly close. Doesn't always work for everybody, but it gets us in the right field. But yeah, if it's wanting to run in the red all the time, or vice versa, if you can't get the bar or the funnel to come up, come in here and just reset sensitivities. Headland's been something that's been out for a while. I utilize it quite a bit on these machines now. So what this is going to do, I'll usually take and open everything up. So whenever you put the machine in headland mode, shift and resume on your header height, you'll get an H where your A is up there in the cab, tells you that you're in headland mode. As soon as that happens, we can set the fan, upper, lower, and pre-sieve all to do something. I usually pull back my fan speed by 50 to 100 RPM, open my top sieve, 5 millimeters, open my bottom sieve 2 or 3, open my pre-sieve 1 or 2, and then all that's designed for is as we unload that machine on the ends, we're not walking or blowing grain out the back. It makes it a little more open to accommodate for less crop. Our statuses page, not something that I even use a whole lot, but it is, if you've noticed, you're still walking grain out the right side of your machine even though you've got an offset in. Come in here and check your inclination sensor, see if you've got your check. May need to be calibrated, maybe the sensor's not reading right and you've got a red X there, and you told it 1 degree and it's putting 1/10 of a degree in. So it's a real quick check just to make sure that all the systems for automation are running the way that they should be. Talked about our ranges. The last tab there is something that I don't think very many people know is there, because I still get a lot of phone calls about this. This pretty well tells you exactly how to set the machine. What case wants you to start with for numbers. Apparently this one's running in older software. They have changed where your inches are here. That's metric now to match what's on the screen. This is what it shows in automation. When you're not in automation, it actually shows a few more things that it's not controlling. But this is always a good place to start for the crop that you're in. If you're not sure, if you got a new operator, you can't get a hold of you, make sure your operators know. You can come in here and this will give you a good starting point to actually get in there and start the harvest. The other thing, and I know Tony's going to talk about it here in a little bit, but our bars and modules. This tells you how many straight bars, how many spike tooth, how many standard Rasp bars you're supposed to have, what concaves you're supposed to have in it, and where they're supposed to be. So, everybody knows we got several different concave options. I've had a lot of people not really sure what Rasp bars they've got on their machine. How many straight bars do you have? How many spikes do you have? How many standards do you have? All of those make a big difference on how the machine operates in different crop conditions. I guess with that, Tony, if you want to talk about, we can dive into concaves and Rasp bars.
Yep. Okay, so kind of cover the setup of the rotor and your concaves modules. Kind of what you saw there for soybeans. What did it say for concaves? Anyone remember what was on there? Large wire, and then skip wire for the threshing. That's how this one here is set up, and that's a good setup. It's a solid setup for corn and soybeans. What you can run into with the wires is when you get in tough threshing conditions, early season corn, wet corn, you might start seeing hairpinning around the wires up in the threshing area. Your two concaves where you're doing your threshing. A lot of times, and a lot of you guys will probably run round bars in the front of it. If in round bars, we can see what the large wires are. Round bars here. This here, we got a couple of years ago. We came out with a different round bar. This is the one that we've had since 2004. It's 17 mil round bars, what we're calling it now. Between these two concaves here, the round bars are the same diameter. It's the gap between them. So we're 17 mils, 3/4 of an inch here. Come over here, we got more gap. It's 25 mil. So in high moisture corn, a lot of times we'll run 3 or 4 of these in the threshing area, the 17 mil round bars. They don't have the wires, they don't hairpin, so that we keep that area open up so that as grain gets threshed, we can get it out of the rotor cage down on the cleaning system and continue on and not fight with rotor loss. Last few years we've been seeing, especially with fungicides, even though we're able to keep this clean, typically we always ran the skip wires in the separation area. We've got conditions where we're starting to see hairpinning of leaf material, plant material around the skip wires. If it gets bad enough, it starts blocking off the area that corn connects at the rotor. We've got these 25 mil round bars, more open than what the 17 mils are. Those work well in green stem soybeans and high moisture corn if you start seeing plugging in the back. The one thing about these 25 mil round bars, never put them in rows 1 or 2. Because they're more open when you're trying to get that threshing action. You got tighter clearances, you're going to go ahead and put more material down on the cleaning system, and you may get unthreshed pods, especially in soybeans. So people will say, tell me what's your favorite setup? Well, how would you set up a combine? If I was going to do a generic setup, one peanut butter spread in our area where we get corn and soybeans are our major crops, I'd probably run in the front right, run a large wire. Similar to this, but bars are further apart. What you have in here, that gives you good threshing action. The square edge bars go ahead, and as soybeans come across it, the rotor's trying to move stuff. Your square edges try to resist movement so that you get the threshing action. Same in corn. You want to take that cob of corn and you want to get it to roll. As it rolls around, that's when the kernels come off. So Any type of large wire concave with the square edges give you better threshing action than what a round bar does. Once we go ahead and come around to this side, we got a fair amount of threshing done. You still get threshing action off this, but it's more open. It starts letting grain out. Second row, run a pair of the 17 mil round bars. And then, especially if people are dealing with green stem soybeans or their early season corn, I like putting a set of 25 mil round bars in row 3, just so we don't get any type of plugging of concaves going on. I've run in the 17 mils, I've run them in dry beans and dry corn. They work good there too. So if I was going to go a generic setup, if someone says, not even knowing their crops, they give me an idea, okay, when do you start harvesting corn, what's your beans like? Probably that'd be a good setup. One large wire front right, 3 round bars, a pair of 25 mils in row 3 for separation. Leave row 4 as your large wire. Usually stuff is chewed up. We don't get as much hairpinning on that row 4 as what we will in 3 in that as we go into the separation area. Now on the rotor, for elements on the rotor, corn and soybeans, these are worn. These came off the machine. I don't have enough money to buy new ones, so I get old ones from the dealership. This is what you'll have. All these rasp bars is what you want in your threshing area. So over your first 2 concaves, standard rasp bars. When we get into the back section, then we start putting some of these. If you look at it, it's got a spike on it. Spike tooth rasp bars, that you got the configuration up there. For soybeans, it says to run 8 non-spikes, or spike and 64 standard.
Spikes. Yeah.
The third element that can be on a rotor is straight separator bar. Straight separator bars aid in separation. What they wind up doing, rather than having the small elements that keep pushing it, it'll go ahead and as it comes around, it takes kind of a big gulp, and as it comes around the rotor, go the right way, it takes a lot of material and gets it to tumble. As it's tumbling, as it's coming across your grates, that's when you get that material to get out the grates, get onto your cleaning system. So as a kind of a starting recommendation for a corn and soybean producer, when you look at the elements that are on there, standard rasp bars, they consume the least amount of power. When you put the spike on it and you get more agitation back in the separation, those start taking more power. These take the most amount of power. So when you're looking at how you're setting up, it's a trade-off for the amount of agitation, separation capacity you got, and the amount of power required to process the crop. So if I was working with a guy that's a wheat producer, the guy's out on a wheat run, they're going to run all straight rasp bars, front to back. When you start getting into soybeans, we needed some more agitation. Then we start putting on, like it says, put 8 of these on. When you get into corn, I like running the combination of spikes and straights. 10 years ago, I would have told you to put 8 straights on. Problem is, when you set up your rotor, you do corn, early season corn, good separation, get that material out. When you get into soybeans, especially green stem, these suck power. They slow you down. So kind of the happy medium on a rotor setup that we're running now. Threshing area, all straight rasp bars. Then when we get into the separation area, we'll run 8 spikes and 4 straights. And if you kind of look at how the rotor, the spiral on the rotor is set up, we drop a concave out there and spin it around, what you're going to find is there's a set of pads where they're in line with each other, where 2 pads would line up where you could put this straight separator bar on. You can't put it in every position, but in row 3, you wind up with 4 positions that you can put a straight separator bar on, and then when you get into row 4, there's another 4. What we're doing now, kind of the good combination between good separation and as little power consumption as possible. Over row 3, we'll run 2 of these, and then where this other set of straight separator bars could go, we'd put 2 of these, or 4 of these, 1 on each pad. So you wind up with, in row 3, 2 straights and 4 spikes, and then you do the same in row 4. Just be sure you balance them, you get them 180 degrees away from each other, otherwise the machine shakes more than it should. Questions on rotor setup?
So something that's kind of new for Bane-Welker, new for myself included. We've got these concaves here from Copperhead Ag. It's kind of a mix. A lot of things that Tony was talking about are included in these concaves. One of the things that my guys like is you put them in, you never take them out. I don't care if you're wheat, corn, soybeans, whatever. It's one set of concaves for everything. We've got a 90-degree cutout in these. So these, I'm sure a lot of you guys have heard of Estes concaves. This is their original patent. Copperhead bought out the patent, just rebranded it as their own. So these got this 90-degree cutout, and that does the same thing as what Tony was talking about with the square edges on the wire concaves. It actually gets that crop to tumble. It's catching the kernels on an edge and rolling them off the cob instead of smashing them into a plate and rolling them off. The other thing that happens is these start to fill up with, you know, dirt, dust, cob, and kernels. So we're actually threshing grain on grain instead of grain on steel. These are just for the first 4 concaves, so just the front half. They've got this cover plate on the back side that allows us to run this set of concaves through every crop. For corn, you run 2 cover plates, the one on both sides here. On R1, for beans, it's L1, R1, R2. So we close that up, we leave the door open. So we do get some separation there, but we hold it inside that rotor area a lot longer. I like these because that door, we're able to slide that door back and forth and really fine tune what we're after. You know, everybody's situations are a little bit different. If we need to hold it in just a little bit longer, all it takes is a wrench and we can loosen them nuts up, slide it over, and cut that opening in half of what it is there, or slide it over 1 inch on 3 cover plates. And we can really start fine tuning that. They are a 1-inch diameter rod. And as you can tell, they're quite a bit more open. I've never run them in corner beans. I've got customers that have run Estes concaves. They love them. They don't run combines without them. I had 2 customers run them in wheat this summer. Both of them said that they got a cleaner sample and had more production. One guy said that he got rained out and it was a week before he got back in, so the straw was drier, wheat was drier. He's not sure how much of that attributed to the concaves versus just a better crop. Both guys said they got a better sample with this concave than what they had originally. The only complaints that I've ever heard from customers that have run these in the past is with certain varieties of corn, they were getting more tips in the tank. The tips would break off and they were able to fall through and then make it through our cleaning system into the tank. The other one was on the cover plate, how it latches over the back side here. It's a wear point. Crop rubs on it all the time. It wears out. He actually had a cover plate fall off, walked it out the system. To me, it's not that big of a deal because I know it's something I need to keep an eye on. It's no different than any other wear point on the combine. But in full transparency, that's what I've heard from customers that have run this concave before. I don't know that it's necessarily an end-all be-all. It's just something that is new for me this year. I want to make sure you guys knew about it as well.
Questions on rotor setup, modules?
Yeah, we have our combine set the corn like you said, it's a large wire on the right-hand side. But, I mean, I go 200 feet and it's completely closed.
The front right?
Yeah, the front right, the large wire, where all the big round bars are clean.
Yep.
So, we'll dig it out, another 100 feet, I'll be plugged again. What should we be doing?
Leave it
I'd dump a round bar in it.
or leave it plugged.
Yeah.
We're-
Being plugged up, it makes more sense to work.
No, and the next thing I'm going to talk about here is like you alluded to it earlier. Okay, if you, and I should have been telling you where I went. If you go go toolbox, hit your back button, go to toolbox, come across the bottom here to cleaning system. There is an offset that you can put in the cleaning system. And typically these combines, soybeans and wheat, the distribution coming out of the rotor is usually pretty good on the grain pan. In corn, the higher volume crop, we tend to get more distribution on the right-hand side. If we get too much distribution on the right-hand side, then it affects our ability to clean. We can walk material out of the back of the machine. So what I did is come in here. You see where we got a sieve offset. A lot of times, 1.5 is kind of aggressive. A lot of times we'll put a 0.5 to maybe 1 degree sieve offset. What that winds up doing at sieve that's loaded heavy on the right-hand side, we go ahead and we raise that up a little bit, and through the shaking action, that heavy stuff moves towards the center, and we're able to do a better job of cleaning without walking material out. To your point, why I said that front right, leave it, it's plugged, don't do anything with it. In corn, if it's only letting out 1/4 of the material that it gets threshed out, what happens is instead of putting that on the right-hand side right away, as it comes around and gets to the round bar, that round bar is more open. We start getting grain out. We start initially putting more stuff on the left side, and then that evens it out. That actually, by having that front right, go ahead and plug up some, it helps with the cleaning capacity in corn. There's still, I mean, you got another 7 modules to let the grain out, and usually we can get the grain out without much problems on those other 7 modules. So when you see that front right plug up, that to me doesn't concern me. You know, you do everything, it's just like if it's plugged up, you know, we got a chance of losing grain. There's still enough area in that rotor to get it out typically. So that doesn't concern me too much. And then like I said, if you get into automation, you're still having problems with the cleaning system. You're fighting cleaning system losses. If you go ahead and go behind the machine, you say, looking at this, what's coming off the spreaders, it's always on the right-hand side. That's a sign that probably that distribution on that grain pan and coming across a cleaning system is higher on one side than the other, and it's going through. What do we got to do? And to help us out, we can come in here and put a sieve offset in. You say, and when you put a sieve offset in, you got the ability to make it positive or negative. Positive should raise the right-hand side and help you out. And if a guy tells me, yeah, I was having problems with my cleaning system, I cleaned it up, or I cleared it up, I went ahead and put a 3.5 degree offset in it. It's like, you got something else going on there. That's way too much. Either that or maybe your inclination calibration isn't good to start with, that it thinks that it's got that one side down and you're overcompensating for a bad calibration on the inclination of the combine.
Talk about some calibrations.
Yep, calibrations.
You guys do your own yield cals, moisture cals, for the most part? Which one are you using? Fast? A lot of fast? I hate fast. Again, it's just like their 4 boxes whenever we're setting our sensitivities. It's a good way to get close, but it's not accurate. Fast calibration is going to get you within, I don't know, 6, 7, 8%. If you're running it across scales and you just want it to be close, do a fast cal and keep rolling. If you're turning yield maps in off of for insurance, don't do a fast cal. If you're tracking bin levels off of yield maps, don't do fast cal. I like doing the advanced calibration. I like being in control of it. With the advanced calibration, it starts before you ever get to this page. But doing an advanced calibration, you'll start a new task. Go in and rename your task. I always say C1. I go out and I'll picking the field that you want to calibrate in is just as important as doing the calibration well. If I'm dumping into you know, one of them little dinky seed guy white trailers that looks like a thimble out there underneath your auger, bottom of the auger or bottom of the back window, it's a really good place. It's about all the more it'll hold. If I'm going on to an auger cart where I can put as much as I want in it and I've got 1.5 mile long throughs and there's no drowned outs, there's no waterways, I'll run till it's plumb full, just about to come over the edge. The biggest thing is I want consistent running. I don't want to be loading and unloading the machine, loading and unloading the impact plate to get that accurate calibration. So once I do that, I'll make one through. If I'm in a short field and I can just barely get up to the bottom of the window, that's as much as I do. So you make your pass, you start another new task, name it C2. At that point, you can come in here, fill out your crop type, your grower farm field, and you'll be able to select that C1 task. Once you select C1, you'll be able to come over on the side and where it shows your percent error, between your percent error and your total cal task, you'll get what it thought was the moisture and a place for you to enter the actual moisture. You can do the same thing with yield, do them both off the same task. I like doing advanced because I want to vary my throughput on the machine. So I'll do 4 calibrations to start with. I'll do one, say we're shelling corn 5.5 miles an hour. I'll do one at 4.7 to 5 mile an hour. I'll do 2 at 5.5 mile an hour, and I'll do one that'll make you nervous. And all that's doing is simulating different load on our impact plate. So we're simulating, instead of 200 bushel corn, we're going to simulate 170 bushel corn. We're going to have 2 at 200 bushel corn, and we're going to have 1 at 230 bushel corn. With our system, we're able to put a multi-point calibration in. All it is a line or a graph. So we know that at 170 bushel, this is how much force we've got on it. At 200 bushel, we've got this much force on it. At 225 bushel, we got this much force on it. So we're able to get a good, accurate calibration across multiple different situations. You go from one variety to the next, we don't have to recalibrate. And the fact that you can do yield and moisture at the same time. There is a wizard. I don't like the wizard, it takes too long for me to do it. What it's going to tell you to do is vary your head width. It's the same thing as speeding up and slowing down, but instead of, if we're shelling corn, it's going to say run at 5 miles an hour, but take, 8 rows of a 12 row. Take 12 rows of a 12 row, and then it calls it good. In my mind, there's a flaw in that because 12 rows and a 12 row at 500 or at 5 mile an hour with 170 bushel corn is the most it knows. If we get into 220 bushel corn, it doesn't know what to do with it, so we're going to lose accuracy there. If you're unsure about how to do a yield cal, run a wizard. It'll give you good accurate calibrations up to that maximum that we can calibrate for with that crop at that time. If you're comfortable with it, if you're not comfortable with it, call me. Call Caleb, call Josh and Isaac, wherever they went. We can all walk you through this over the phone. We've done a million yield cals. Don't be scared to do the advanced one. I've got a lot of guys that are scared of them. Once they see me do it a couple times, it's really pretty easy and you get a lot better calibration out of it. The other tab here is our Calibrate tab. We got a ton of different calibrations here. I'm guessing most of you guys have done your own header cals. You know that it walks you through it pretty well step by step. Every other calibration here does the exact same thing. I'd recommend doing most of these calibrations before you get started. I mean, do your header cal, do your pre-sieve, do your top sieve, do your bottom sieve, do your concaves, rear wheel position, and steering valves is kind of a minimum. You know, automation's great. You know, with this room, there's a lot of guys that have run automation. So far, I haven't heard too many guys telling me that it's a load of shit and it doesn't work. So I feel like we're probably onto something here. It's only as good as what these calibrations are, because if it thinks, you know, if we run a machine 3-4 years, our sieves are got a little bit of slop in them, our actuators aren't quite what they were, so it opens to, you know, 13 or 25. Say it opens to 25, or what it reads on there is 25, but it's actually 12. Our automation is not going to run any higher because that's all the higher the system thinks it can go. So if we're having problems with cleaning system and you look down and go, well, the damn thing's saying it's at 25, it's as open as it can get, you get in the back of the machine and, you know, they're half an inch open instead of an inch open, that's a calibration issue. Something that we can resolve really pretty quick if it does happen. 6 millimeter is what you want to gap those to whenever you calibrate them. I use an Allen wrench. So it's something easily done sitting at the barn lot before you get started, before you got, you know, 5 trucks sitting there and a grain cart driver and dad yelling at you saying, well, why aren't you running? Well, I got to do my calibrations. We can do those now and actually make sure automation is going to do what it's supposed to do whenever it's time to run. I'm not going to go through all these calibrations. Like I said, they all kind of tell you exactly what you need to do to perform that calibration. The Allen wrench, I get a lot of the questions, well, how am I supposed to gauge what 6 millimeters is? I've got a 6 millimeter Allen wrench, slips right in there, and I can close it manually from the back until it fits, and I know that it's set right.
Yeah. And I've run across that before on working with customers struggling with automation. The one I remember is we couldn't, sieve loss, we was fighting sieve loss in the 28% corn, and they stopped for a break. And when we got out of the cab, I looked over there, and pre-sieve was at 14, upper sieve was at 25, lower sieve was at 20 itself. They went for an evening break for dinner. I poked my head in the back, and the upper sieve was open about that far. You guys good with metric? Is that 25 mil? It's like, oh, there's problems. So I went ahead and I didn't even get some people will scream at me for saying it. I didn't even get an Allen wrench out. I got close enough to 1/4 of an inch on pre-sieve, upper sieve, lower sieve from doing this quick while they're having their evening meal. Went up in there, hit calibrate pre-sieve, calibrate the lower sieve, calibrate upper sieve. We went in after we made 2 rounds, the losses had went down, and that top sieve that was at 25 mil had backed down to 21 mil then. Because with the ranges that we talked about before, the max that we can do on a sieve opening is 25 mil. And once it gets the reading from the actuator and it says I'm at 25 mil, it's not going to hit the plus button again and try to open it up more. I'm at 25 mil. But in reality, it's probably at about 8 mil. So that's where your calibrations come into play on this. If your calibrations are off and you're up against one of the range limits here, it can't go any further. I'm to my max, I can't go any more. So keep that in mind. So your calibrations play an important. If you had a 240 machine and you're fighting sieve loss and the thing said it was at 25 and you're fighting sieve, you keep hitting the plus button. It doesn't change 25, but the sieve is actually opening until you actually get it to where it's acceptable for you. With automation, once it's there, I got to stop.
I'm Rick. Been here at Bane's for about 17, 18 years now, so I know the majority of you guys, but I'm the service tech. I'm the one that comes out in the field and takes a look and works on these machines. Basically, the first thing I'm going to tell you, safety. Let's always practice safety when we're working on these machines. Let's put the header latch down. One thing that gets missed is on the grain head. When that reels up and you're working on that sickle. I've seen hydraulic hoses break and it don't take but a second to drop that reel. So put the safety latches on, shut the key off, just protect yourself. Okay, sorry I can't talk that loud. Second thing you need to really look for this time of the year, before you even turn that key on, climb up that back ladder, look inside that radiator, look around that engine area, make sure we don't have coons. That's a job I don't like, and that could be a $10,000 to $12,000 part. Whoops. It don't take long to take out the coolers and the radiators, and so do that from this time, every time you start up.
If you see ice staring at you, don't start it.
Not a good day. Okay, basically we're going to start up here in the front of the machine. I usually take a look at the plate on your tracker at the bottom. That is actually a wear area that, as that grain comes off the head, it'll wear that plate out. And we do sell a replaceable weld-in plate that you can put right there. Then I come up the side and I'm looking at the feeder floor. Feeder floor is a wear area too, so check it for cracks and stresses and whatever have you. Another thing that I will do on the feeder, you see the spring-loaded chain adjuster. Take that apart, clean it out. Take that there's like a little tube in there, slide that out, clean the threads. What happens is dirt gets up inside that tube and it stops that spring action, and then you can actually loosen the chain. All of us had the chains that jump every once in a while. That could cause that. So I always make sure to do that on an annual basis. So then, as we walk up the top of the feeder, you're taking a look at your sprockets. We're taking also a look at the spline wear on the top of the sprocket. So basically you can grab like a beater and rotate it. The feeder sprockets should relatively be turning as you're turning the beater. Now that machine right there, the top gearbox is a 1000 spline, PTO spline. Here we've got a coupler and the larger spline to take out some of that wear area.
Yeah, on the 250 series, for the rock trap beater and the top feeder shaft, we went to a different coupler in here where this goes on your output shaft of the gearbox. Then we got core splines that's coming over here that's actually driving the top feeder shaft. So on the 240 or the 250 series, we put this in. We can't retrofit it back to a 230 or 240, but this has helped a lot with that wear on that top feeder shaft and your rock trap. And there is a grease point here that you need to go ahead. I think we got 150 hours on it.
Yeah, anytime you're in there, just make sure you grease it.
Basically, when you switch between crops, pre-season, switch between crops, throw some grease in there, keep that lubed up.
Right. Same way on the older machines. We want to keep it greased up. But with the larger splines, it takes a little bit of that gearbox straightness. I mean, it's kind of hard to get that gearbox perfectly straight with the beaters and the feeder shaft. That larger spline takes some of that guesswork out. Next thing we do is we follow on through. We take a look at the transition cone. We take a look at the wear. It's usually going to wear at 12 o'clock, 6 o'clock, 9 o'clock, and 3 o'clock. What I like to do is take number 1 concave out. You can take that, drop it down. You can actually reach in right at this first vane at the 3 o'clock area, and you can feel the wear on that transition cone without doing a lot more taking apart. We sell new transition cones, we sell liners, whatever it takes to get you guys going. Another place to look for wear is on that upper cage in the same area on the other side. Just reach straight up and you'll fill veins up in that area. That is another area where all your crop starts turning right there, and that's where it starts to wear through. They sell liners up for that up there also. So then you come back and you take a look at your rotor vanes. Make sure that your rotor vanes are good and square and straight, not bent over by a rock or something like that. Another area you take a look at on these machines that have like the 50 series on up, that have the adjustable cage vanes up here, there's a turnbuckle here. We've had issues with that turnbuckle breaking, and you will know it immediately. Your horsepower will just tank. I mean, it's a horsepower robbing. It's going to throw them vanes all the way to the slow side, so you will know. But that's a good place to kind of take a look, make sure the bolts and everything are in good, good and tight. Make sure everything is in good shape pre-season. Coming on back through here, obviously Tony hit on the Rasp bars. Like he said, this is wore out. What I typically look on the Rasp bar, oops.
You're good.
What I typically look at on the Rasp bars, I'll look at the bolt head. If you stop, if you can't see the markings on your bolt head anymore, you're typically wore out and it's time to get rid of it. It's going to wear harder on the front, and you'll see it gradually come back. You can put half set Rasp bars in, typically 2 in the front versus 1 in the back. Coming on back, we take a look at your chopper, okay, your chopper knives. You want to keep them at a pretty good cutting edge. You don't want them to get rounded over and, they get too rounded over, too blunt. That just takes out much more horsepower to push the stuff through, plus we get longer stems out the back. When you change your knives, your rotary knives, if you break one in the middle of the season, make sure you put a set of 2 on opposite sides. That way we keep that rotor in balance. Kind of moving on back, we're looking at the spreader and everything. We'll check the spreader, the motors for leaks, the impellers for bends, brakes, whatever have you that way. Then we kind of go through looking at chains. We'll take a look at all these chains. Did I do that again? Yeah. How I usually tell whether a chain's wore out, the quickest way is you wrap it around, tie it around that sprocket by hand, or make sure it's tensioned correctly. You can go on the back side of that sprocket and start pulling that chain up. You're riding on top of that sprocket. Put a new chain on there, get rid of the premature wear on these sprockets. So we'll take a look at all the chains on the machines. We'll take a look at the belts, check them over, roll them over, make sure there's no cracks, whatever have you in there. Let's see what else. Elevator chains, you want to make sure you keep them tensioned all the time. Check these chains. You check your feeder chain, check your elevator chain quite often. We need to keep those tight. On the elevator chain, the key rule how you check those for tension, you should not be able to hardly pull that chain link off the sprocket, but you should fairly easily be able to move that chain link side by side. That's correct tension on that. Another thing while you're in that elevator, check is your little divider plates. That bottom plate right there, that is a wear item. And I've actually had one this year that wore in so deep that the chain rollers were actually bouncing off that plate and creating a vibration all the way up into the cab. Change that plate out, vibration went away. So it does wear. Most of the times you'll see a crack before it wears in that deep, but they do wear in, so take a look at that. The other area of wear is the lower boot, right where that grain comes off your augers and drops into that elevator, that is a wear area too, right there. So watch that. Watch your troughs, check your troughs for, wear, because quite frankly, we're running a lot of grain through these machines, a lot more than we used to. We go back up, we take a look at the augers, wear on the augers and everything up in the tanks. We take a look at the augers, make sure your tubes are not getting thin and distorted. When you look at the unload elevator up here, or unload auger, 90 degree, and we check that for wear, because they will wear over time and start to give. It seems more prevalent in the older machines than it does this. These here have got a bigger, heavier duty cast iron 90 degree. Going through, checking your gearboxes. I mean, we got final drives, we got feeder header, unload. Your top feeder gearbox, let's really watch that one close. That's got clutches in it, so you start to notice the oil getting a little dirty or whatever have you. Could be a clutch issue happening, but at least get that oil changed. Another one would be this unload gearbox. It sits out in the fields a lot, get a lot of rain. You could get water egress down inside there, so definitely take a look at that oil and make sure it's not milky. Trying to think. Another area you kind of look at back here is you want to look at your axle and your pivot points. I mean, we're carrying a lot more weight, a lot more load on these machines. They can start to crack out in some of these pivot points. So just kind of a quick area. One thing you can do pre-season, and what you really should do, is take a look at your tire pressures. Make sure your tire pressures are inflated to the book. What they're going to do is you can go into your operator's manual. Different tire sizes hold different air pressure. Different heads react to how much pressure you need to put on that. So let's keep them tires inflated. I'm trying to rush through this.
Tailings processor, anything on that?
Yeah, on the tailings processor, you need to really check where the mounts are at, and it's more times more prevalent at the top of the tailings processor. She'll start to crack out over time, and you will have to end up possibly be replacing that. They have increased the metals on these machines now. The older ones were pretty thin. I haven't had much issues on these, but just anywhere it mounts, take a look at that, and obviously take the belts off, roll all the idlers and everything, make sure we don't have any kind of bearing issue. I'm trying to think. Obviously, you want to check your PTO oil. When you check your PTO oil, your rotor gearbox oil, pull the dipstick out, wait a few 5, 10, 15 seconds, wipe it off, put it back in, then pull it back out and check it. The oil tends to seem to want to cavitate out of that tube. So, like I said, by pulling the dipstick out, it allows it to fill that tube back up to get you back to your proper level. Let's see. Just like he was also saying about your header height control, you want to make sure pre-season, let's get it out, get them calibrated. And then what you want to really watch for is in this left-hand area. If you're let your head down and you're in header height control, you should see a wavy line underneath the corn head. If you see a flat line underneath the corn head, you did not get it calibrated correctly, or it's not sensing the ground, you have a sensor problem. So yeah, make sure you should see a wavy line when it's on the ground and float. So, anything else you think of?
No. Working with dealers for many years, and I'm going to say before you go to the field this year, 2 things that you can really do to help all the techs out. Before you go to the field, number 1, have your combine out, make sure the air conditioner's working and that your header height's working. Get that done between now and your first day of harvest, so if something is wrong, you can get Rick or one of the other techs out to get that resolved for you before you get to the field and you got the grain cart and 3 semis sitting there and saying, I can't sit in this combine, it's too hot. Or I can't pick because my header height's not working. If you get those 2 things done ahead of time, if you have a problem with it, let these guys know, let them get it fixed before the whole crew is out at the field waiting on the combine.
And it's really easy on these Pro 700s to look at the, well, maybe.
Well, you're in calibration now. Just hit header.
I'm trying to go back. Oh, I'm trying to.
X.
Oh, okay. Yeah, there you go. I'm talking like for just checking your header height sensors. Go to diagnostics. Come over here to settings. Come up here to group. Maybe. And then go to header height and tilt. And then come down here. And you can pick whatever sensor you want to look at. So I want to look at, say, header sensor left. Then come over here to graph. And if this was plugged in, you should see a voltage range right here. Okay, so when you're on the ground, it'll be 1 voltage range. When you're off the ground, it'll be another. It'll actually show you a bar graph. You want to basically keep them sensors above 0.5 volt and below 4.5. I like to go just a little bit more like 0.6 to 4.3 or something like that. That's what this machine likes to see. So when you're setting up that header calibration and you get an alarm, it's going to prompt you to go to this page so you can see that sensor, whatever is incorrect. So basically, to do the calibration for the header height control, on this one you go hit header, under your calibrations. Actually, I'll back up a little bit. You want to go to toolbox, go to head 1, answer every question in head 1, go to head 2, answer every question in head 2. Then you come back to the calibration screen, go ahead and perform your header calibration.
You can keep talking, Rick.
Okay. And what it's going to prompt you to do when you're in header calibration, well, it gives you your instructions right here. But then I like to make sure I'm at least 1/2 to 3/4 throttle so the hydraulics are running at full capacity. And then it's going to prompt you to pulse header up or pulse header down. And so all you have to do is just hit the button and just stand back and let it do its thing. It's about a 4-stage process. When it's done, then you go back up in the cab and set your height points, your header height 1 and header height 2. And you should be good to go, and then all you have to do is just cycle your header button on the console. So, anything else you can think of?
No.